A key development has taken place in the domain of manned-unmanned collaboration for aerial combat. In a landmark demonstration hailed as a major leap in human-machine teaming, the U.S. Air Force successfully tested the integration of autonomous collaborative platforms, ACPs, with crewed fighter jets. During the exercise at Eglin Air Force Base, Florida, pilots aboard an F-16C Fighting Falcon and an F-15E Strike Eagle each commanded two XQ-58A Valkyrie unmanned aircraft in a coordinated air combat training scenario. In this video, Defense Updates analyzes how the XQ-58A Valkyrie, controlled from a piloted fighter, can be a force multiplier. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. According to a press release from the Air Force Research Laboratory, AFRL, the integration of the XQ-58 Valkyrie into air combat scenarios aims to reduce pilot workload while improving situational awareness and overall mission effectiveness. The test was part of a broader collaborative effort supported by the Department of Defense's Rapid Defense Experimentation Reserve (RDER) program under the Office of the Undersecretary of Defense for Research and Engineering. It was executed through a partnership involving AFRL, the Air Force Test Center, Air Combat Command, and the U.S. Navy. The press release further added that ACPs provide affordable, runway-flexible capabilities that can operate semi-autonomously in high-risk environments, while enabling operators to retain strategic and ethical oversight. The ethics of having these unmanned force multipliers flying around autonomously in contested environments has been in the spotlight since the beginning of these tests, with the Air Force and industry committed to building AI technologies that are responsible, equitable, traceable, reliable, and governable. AFRL has stated that data from the recent flight demonstration will inform future development and deployment of semi-autonomous capabilities across the Department of Defense. Brigadier General Jason E. Bartolome, commander of AFRL, stated, "This flight marks a critical milestone in advancing human-machine teaming to address complex threats and enhance our operational edge. By integrating autonomous platforms with manned systems, we gain the agility to rapidly adapt, boost combat effectiveness, and reduce risk to our air crews in contested environments." General Ken Wilsbach, commander of Air Combat Command, said, "This test with ACPs directly addresses the evolving requirements of modern warfare and the needs articulated by our warfighters. We are committed to innovation and integrating ACPs through these kinds of demanding, operator-driven evaluations that allow us to learn rapidly and enhance our human-machine teams. This approach is fundamental to sharpening our combat capabilities, maintaining air superiority, and ensuring we can effectively support the joint force in complex future environments." Valkyrie is developed by San Diego-based Kratos Unmanned Aerial Systems, which was given the contract by the Air Force Research Laboratory. The project falls under the Air Force Research Laboratory's Low-Cost Attritable Aircraft Technology (LCAAT) program. The program is initiated to develop cheaper unmanned tactical aircraft. The aircraft progressed from contract award to its first flight in 2019 in just 2.5 years, showcasing the advantages of rapid acquisition and streamlined commercial manufacturing approaches. Valkyrie is designed to act as a loyal wingman that is controlled by a parent aircraft to accomplish different tasks. It can support a variety of missions, including strike, ISR, electronic warfare, decoy, and comms relay. For instance, it can carry 2 small-diameter bombs or compact electronic warfare equipment or surveillance systems. Valkyrie can take off from a short runway like a plane, or can be launched into the air via a rocket and recovered via parachute, making it runway independent and highly flexible. Future variants could be developed for operation from aircraft carriers. The Valkyrie's design incorporates a stealth-optimized fuselage, V-tail, and internal payload bay. It has a max speed of around 652 miles per hour or 1,050 kilometers per hour. The platform has a long range of around 3,000 miles or 4,820 kilometers. Kratos officials have said the company could produce 250 to 500 Valkyries per year. Importantly, Valkyrie is relatively inexpensive. As per Kratos, it can be produced at a unit cost of $4 million at an annual production rate of 50 aircraft, and possibly for less than $2 million if over 100 airframes are built per year. This estimate roughly equals the cost of a single, non-reusable Patriot missile. In comparison, for the price of one F-35, estimated at around $100 million, up to 50 Valkyries could be acquired. The value proposition becomes even more compelling when factoring in the high maintenance costs associated with stealth fighters like the F-35. XQ-58B, an electronic attack version, is currently under development for the United States Marine Corps. It is intended for use in the seed role as a collaborative combat aircraft, to be operated alongside USMC F-35s. Human-machine teaming stands at the cutting edge of the U.S. Air Force's modernization efforts, driven by the need to operate effectively in increasingly contested and complex environments. Unmanned platforms are seen as a vital component of future air power, providing credible mass to support crewed aircraft and enabling greater operational flexibility. What is being achieved with Valkyrie would have a significant impact on the way the U.S. military fights its future wars. Valkyrie with manned platforms would present a different kind of challenge for adversaries. The Valkyrie's compact size and stealthy design make it difficult to detect and track, posing a significant problem for enemy air defense systems. Its low cost allows for deployment in large numbers, enabling saturation attacks that can overwhelm even advanced defenses. In a 2021 test, the Valkyrie successfully deployed an Altius 600 small unmanned aerial system from its internal bay, demonstrating its potential to serve as an airborne launch platform for loitering munitions or other unmanned systems. When equipped with varied payloads, some carrying electronic warfare systems, others armed with precision-guided munitions, a swarm of Valkyries can effectively penetrate heavily defended targets. Even if many are intercepted, some are likely to slip through and strike critical components of an air defense network. Its long range further enhances its utility, allowing it to be launched from standoff distances, safely away from hostile threats. In a combat scenario, Valkyries could be tasked specifically with targeting air defense assets, clearing the way for stealth fighters like the F-35 and F-22 to engage enemy aircraft. This tactic would significantly reduce risk to U.S. pilots and aircraft, strengthening America's ability to confront near-peer adversaries such as Russia and China.